Thanks, Gillian. So, good afternoon, folks. My name is Jason Lawson. I'm a solutions engineer at Liberty IT. And what I'm going to talk about and share with you is our experience of building out an event-driven architecture in the cloud. So before I start into that detail, for a little bit of context on Liberty IT, we are part of Liberty Mutual Insurance, which is a Fortune 100 US-based insurance company. And as you can see from the stats there, it's one of the major insurance carriers in the US. And LIT is a software house with sites in Belfast and Dublin, providing software solutions for Liberty Mutual. We are active in the business community, recognized as a great place to work. We have 3 AWS heroes, Gillian McCann, Gillian Armstrong, and Matt Coulter, along with 4 AWS community builders. Those are Darren Broderick, Matthew Dorian, Peter Reed, and Jared Stewart. You might see them representing us at various conferences and events like reInvent. So let's dive into the main content then. I'm going to talk about elements such as our guiding principles, the architecture that emerged, the many challenges and learnings along the way, along with the benefits we have gotten from the experience. I've also got a cheat sheet on AWS eventing coming up, so get your camera phone ready for that slide. Let me start by putting the mission we had in context. The program was started about 15 months ago to reimagine the claims handling experience within Liberty Mutual for workers' compensation. The goal was to build a new claims platform on a modernized tech stack using our cloud provider of choice, AWS. A vendor product would provide a number of capabilities out of the box, and those would be augmented by cloud-native capabilities built by around 15 teams, and each team's your standard 2-pizza size team. Once complete, the combination of vendor product and Liberty-built capabilities would enable our claims specialists to use this new platform when managing claims, and the company can retire the existing claims platform, which is over 20 years old. So it's a large program facilitating retirement of a platform that has served the company well, but is ready for retirement. In terms of architecture, we had a blank AWS canvas on which to draw our foundations and determine how we would build the capabilities. To help guide our decision making and highlight what are the most important tenets to keep in mind for all of us in the program, remember we're 15 odd teams, so it's a lot of people, we put together some principles. And these are those core principles. So first one, in no particular order, is serverless first. Gillian's spoken a little bit about that. This doesn't mean we use serverless exclusively. It means it's our first avenue of exploration, as we see tremendous value in serverless. But we know there are other alternatives, which we do use, and we always want to find the best option for business value. Team autonomy. So with 15 teams all building capabilities, many of which would need to communicate with each other, designing for autonomy was vital for our program delivery, so we wouldn't be sunk by teams waiting on other teams to build something and having just a large dependency chain build up. With many agile teams, that means, of course, many interesting team names, such as Data Avengers, Ghostbusters, and my personal favorite, Silence of the Lambdas. They even have they even have their own logo. And cloud patterns is another tenet. We want to have an awareness and understanding of what patterns people use in cloud to solve business problems and leverage and reuse rather than reinvent where possible. We're seeing increasing examples of off-the-shelf cloud patterns, like a gateway talking to a Lambda to a database. And we want to look at those and use those to accelerate our own delivery. Event-driven, with a platform of this size and need for team autonomy, we want to be event-driven where possible and keep our platform loosely coupled and scalable. Fifth, well architected, we make use of the AWS well architected framework. For those not familiar with it, it provides architectural best practices across a number of pillars via a simple to complete questionnaire that will review and suggest ways to improve your workloads. And finally, customer experience. You know, the rest, the fancy tech solutions, speed to market, best practices, that doesn't really all matter if we don't keep in mind the experience of the folks who are going to use the system. We don't want to build something that looks great technically on paper, but customers struggle to engage with positively, or doesn't enable them to do the best job they can. And this is really, really true with our new workers' compensation system, as the folks talking to the claims specialist may well have had life-altering incidents, so we want the experience to be as simple and stress-free as possible. So I'll just dive into a quick bit about event-driven architecture tenant and how we approached it. So what is event-driven architecture? Well, the textbook answer is something like this: a paradigm using events to communicate. An event is a significant change in state, and events happen and do not know or care if parties are interested in them. But to make that resonate a little better as an analogy, ordering coffee at Starbucks is an event-driven process. The process isn't a single synchronous interaction between you and another party. There are multiple people involved in the process: taking an order, making the order, take payment, deliver coffee, each triggered into action by some event in the process. And some of these actions happen in parallel. So the process has more moving parts and interactions, but it's faster and much more scalable. So Starbucks can achieve more throughput with this model. And in the same way, we want speed and scale for our system. So that kind of sums up why we want to use event-driven architecture. We've that loose coupling between our producers and our consumers of events. It's asynchronous, non-blocking, and allows for real-time communication, independence, and we get the scalability. So as our architecture started to emerge, we brought the principles, mission, context, and patterns together. And we want to combine all of that. So teams would own domains of capabilities is something we considered, such as payments or communications or document management. The vendor will be admitting events that need distributed to those domains. The domains may need to communicate with each other, and the domains will contain many deployable microservices. There's a number of services that would make up, say, a payment system or a payment domain. So constantly talking about those ideas and domains, it reminded me of Eric Evans's book, Domain-Driven Design. It's a comprehensive book with lots of great content on patterns. It's really worth reading, but it is a tough book to get through, I find. But its bounded context pattern seemed like a good fit for what we wanted to achieve and would support our principles. And as that's a proven industry, it's been used by many companies, it gives us confidence that that's something we can adopt and use. So how it looked was, in terms of architecture, something like this. We have a series of bounded contexts that would be delivered events somehow by something which originated from the vendor product and came to our cloud via an API gateway. The challenge now is what replaces the question mark on this diagram. How do we create an event hub that can receive and distribute events to all the domains? And as you can see, those bounded contexts, within that, there could be multiple services being orchestrated. It could be gateways talking to queues and lambdas, maybe back to our on-premise systems, or maybe just doing some processing and storing something in a database in the cloud. So lots of different services using different managed services. So how are we going to connect events to all those different contexts? Now, AWS is our cloud provider of choice, and there are a huge number of services in the AWS ecosystem, and many that can support forms of eventing. And as Corey Quinn points out in this tweet, as well as the most well-known services like SQS, SNS, Kinesis, EventBridge, there are another 10 or so you could use depending on your context and goals. So with so many options, how do we make good initial decisions? And how I've approached this is to determine what attributes are and are not critical for my context, and then line those up against the corresponding attributes of the various services. So this does need a reasonable amount of reading of the AWS documentation, but the upfront research is well worth the investment in my experience. In this instance, some of the attributes important to our context were delivery of events to a large range of targets. You can see from the previous diagram, we could be going to gateways, lambdas, or some sort of queue. Our preferred model is pub/sub, and that's so that the teams can define and have the autonomy to decide what they want to subscribe to. We want scale, of course, as our user base grows as the application and platform is rolled out. And ordering is not critical for the event distribution. Now, interestingly, it could be important within one of those bounded contexts if someone's using a certain service there, but that's something those teams can look at and figure out. For the event hub we need, ordering wasn't critical. So with that in mind, I came up with my cheat sheet. So this is where you can grab your screenshot to extract what I generally find to be the most important considerations to guide decision making. There is plenty of stuff not here, but a lot of what is here really helps me figure out pretty quickly which of the most well-known and mature eventing services can suit my needs. So we have the two types of an SNS, for instance, two types of SQS, EventBridge, Kinesis, DynamoDB streams, and those are just some of the most popular ones. With this, I can look at the subscriber setup very easily. If I need one-to-many, I can rule out some options immediately. I can think about latency and how important that is to the system I'm designing. I can see what ordering is enforced. I've got links there out to the limits and quotas, which have far too much information for a simple table, but it reminds me to get into that detail because those aspects are really important. The bottom row there is quite interesting, the integrations target. As you can see immediately, EventBridge, for instance, offers many more than the other options. And when I think about the attributes I previously said were important, such as being able to communicate events to many targets and that ordering isn't critical, looking at this sheet, there are a couple of options that do work, but it becomes clear that EventBridge is the first option we want to look at. It seems initially like the best fit. Now, we hadn't used EventBridge before, so we did a quick POC to stand the bus up, dug into the service quotas and limits to check if it can scale and deploy as we need it as well. We also chatted with the AWS team to understand the service a little better and how they were thinking of it in terms of use cases, roadmap, and philosophy. All these conversations were pretty positive. We did find some caveats that we thought we could manage, so that meant our architecture was coming together. EventBridge felt like the best decision over all the other options. We could have used some others, but with the knowledge that we have at this point in time, EventBridge was the best choice. So that's what the architecture now looks like. We have our vendor emitting events coming into an API gateway. Those events are published to EventBridge, and teams are able to write rules in their own bounded context to subscribe to those events. So the fact that teams can write rules in their own context is really great autonomy for the teams. And we have an event hub that can deliver to many different bounded contexts that use many different services as the event receiver. So again, giving teams lots of autonomy in their bounded context to expose their services as best for them. We can have teams spinning up services with Lambdas and DynamoDBs that are fronted by API gateways or different queues with great ease. And this is flexible, scalable architecture guided by our principles that empowers our teams to build the services they need to with the autonomy they desire. And that's our current architecture for the platform right now. The EventBridge is really doing some of the choreography, and then within the bounded context, the team are doing a lot of different types of orchestrations, and they may have some choreography between the bounded contexts as well. So in terms of the benefits and challenges, when I reflect on the journey to that architecture, these are some of the benefits, the key benefits I think that we've realized. The decoupled and evolutionary architecture, the bounded contexts are decoupled, the architecture is flexible, and if the AWS offerings do evolve and we wanted to switch out EventBridge for something else, we would be able to do that. It goes back to that Lego analogy Gillian was talking about. It's not trivial. It wouldn't be trivial. It's not simply changing blocks if we did want to move out EventBridge. But if a better managed service came along and we wanted to change to something else, or there were imperatives from the context of our business that meant we needed to change, compared to monolithic architectures or having systems using components that we don't own ourselves and an event hub managed by an external team, it's going to be a lot easier for us to make those decisions and change that architecture as we go forward. So we're set up to evolve in a much more autonomous and in a way that gives us ownership. The team autonomy has many benefits. A really big one is development speed. Teams are now positioned that they can build new contexts and write their own rules to process events. That architecture is highly decentralized, which gives the team a lot of ownership independence, and that translates into velocity in terms of their 2-week sprint deliveries. And all this is serverless. I'm sure folks have heard a lot about serverless. So all the benefits in terms of removing operational burden, managed provisioning, and cost apply here. But it's not without its challenges. One was centralized versus decentralized bus for EventBridge. So understanding the different implementation models for EventBridge was initially very challenging. We looked at centralizing rules with the bus so that we could have things like reuse and maybe a certain type of governance model around what events are created and how they look. This was really hard to manage from a deployment perspective, and having all those teams wanting to consume events. Circular dependencies, for instance, would come into it, and it just made deployability very, very challenging. So we wanted to understand the philosophy a little bit more, so we had really good conversations with AWS on EventBridge and how they envisage it being used. And as we discussed our use case, it became clear a highly decentralized implementation was needed for our context. The interesting thing is that within a bounded context, a team could choose a completely different implementation model if they wanted to use an event bus in a bounded context, because they don't have the same concerns over ownership and distribution that our core event hub does. So it's interesting to think about how even using the same service can mean thinking about completely different implementation models, just depending on what your goals are. Another challenge is that the options can feel overwhelming. That cheat sheet's just a small number of services, and the docs are large. So having some method of understanding the core use cases and attributes of each service, like your own cheat sheet or quick reference, is a way to make it feel more manageable. I use my cheat sheet all the time. Even though I'm pretty familiar with all those services now, I still go back and reference it when I'm designing new workloads, add new services in, and update the information, because the information does change as AWS build out new versions of those services and tweak them. And with making a number of decisions up front, doing some POC work, building momentum can feel tough. I think especially in an agile environment where aspects like design and research are hot topics and can be tricky to balance with demoing value every couple of weeks. So getting the wheel moving felt hard. In this instance, I think having open conversations with teams and with stakeholders to gain the support and trust for the journey can make a really big difference to just everyone feeling more comfortable and confident with slowly building that momentum. And finally, a challenge is the possibility of creating a God event. This is similar to the object-oriented anti-pattern of a God object. As teams look at existing events, and we all very much can have a reuse mindset in terms of our programming background, they may ask for attributes on an event to be added so that they can use that event and a slightly different version of that event rather than generate a new event and take the time to build that new event or ask for that new event to be emitted. As an event can get larger and larger with more and more attributes, there's a real danger of a God event anti-pattern. So it's important to be really diligent about what an event contains and making sure what it does contain is all relevant to the change in state that occurred that triggered that event. I wouldn't be afraid of creating more events rather than trying to bloat individual existing events. So the learnings and takeaways, what are the big learnings and takeaways we've had from this experience? If there's one thing to take away, it's that there's real value in determining some principles and combining that with your mission context, especially if what you're building involves a large number of teams. Eventing in the cloud has a huge number of implementations, managed services, and patterns. And whilst exploration is important, you'll need something to help guide you, or you could just get buried under an avalanche of queues, buses, brokers, and various message delivery systems. And setting up teams with aligned autonomy, and by aligned autonomy, I mean figure out the guardrails rather than just leave it as kind of a Wild West, so teams maintain alignment with those principles and with each other to an appropriate extent. Within those guardrails, let them have freedom to explore and try different approaches. But across the program, there's some guardrails and alignment so that we're all traveling in roughly the same direction, but still leave scope for innovation and new ideas and new services to be brought in. Invest time initially. I mentioned earlier that design and research can be contentious subjects within the Agile community. My experience has been that investing some time up front when faced with a myriad of options will absolutely pay off later in terms of individual team velocity. So I think, especially if it's a large thing, a large application you're building with lots of teams, try to take a long-term view. That speed will come with good research up front. This is a slightly more technical takeaway to think about in terms of cloud providers, but I think of the limits that managed services have as enabling constraints rather than simply constraints. The limits can help you reason about the philosophy and the appropriate use cases for a service rather than just viewing them as a potential blocker or something you want to request to have altered. And one gotcha we find is that regions in AWS can vary a lot. AWS has 10,000 events per second throughput in US East, but only 600 in some Asia Pac regions. That's a huge magnitude of difference to be aware of if we want to go multi-regional. Now, some limits are adjustable, but it's an example of where just looking up at that upfront research can be of huge value. And finally, the well-architected framework. I would recommend anyone building on AWS to use the well-architected framework. We have found it a great tool for reviewing our workloads. And with the conversations it's initiated, we have pulled out plenty of additional services to improve the quality of our workload and consider aspects we originally had not thought of. And that's the journey we have been on. We're going live with the platform in a few months. At this point, we are up to around 200 services across over a dozen bounded contexts. And our architecture so far is proving resilient to all our testing and our alpha and beta results. So we feel in pretty good shape with this architecture, but we're always looking as well to the future and what we can continue to evolve. And we're really excited for it to go fully live over the next couple of months. And that's my talk. So thanks everyone for listening. If anyone does have any questions or wants to ping me, you can find me on Twitter. Thank you.